How you going, guys? Curtis from Cutting Edge Engineering. Today's video we are revealing our SIP Hydroptic-6 Jig Borer. A jig borer is a machine that was invented for the precise and accurate positioning and centering of a hole. This wasn't designed for heavy milling. They were designed for light milling, but to keep the accuracy in the machine, they were really only used for drilling, reaming, and boring. So I've had this machine in the workshop for the past 9 months. The way I come to have this, I was going to Newcastle to see my tooling supplier for the first time. I'd booked in a time slot to go and visit this in person. I ran out of time and I wasn't able to go and have a look at it, but I bought it anyway. When the machine arrived, I organised a 25-ton Frenner crane to come in and unload it from the truck and bring it into the workshop. We got it unloaded, no dramas, brought it around to the back of the workshop. The crane operator was complaining about headroom, that he probably wouldn't fit underneath a few things. I was pretty busy that day, so I said, look, just leave it there at the doorway and I'll sort it out. So they dropped it there and it sat there for 6 months. The plan was to always have the jig borer here at the back of the workshop. It is the cleanest area, so it gets the least amount of dust. I also had a bit of a hurry up to move it because the Mazak was coming over from where it used to live. I wasn't going to be able to get the jig borer past the Mazak once it was in place, so I used my yard crane to lift it up from the front of the workshop and I snuck it around the back of this lathe and placed it right where it is. So now we're going to show you exactly what this is and how it works. This is a SIP Hydroptic-6 Jig Borer. It's made in Switzerland and we believe it is an early 1960s machine. So the tolerances that can be achieved with the jig borers is absolutely incredible. So a machine that is 60 to 70 years old, you can achieve a tolerance of 0.001 of a millimeter, which for something that age, that is amazing. Even in today's standards, with all of our technologies we have with digital readouts, this will be a far better and more accurate machine than a lot of the stuff that's on the market today. There's not a great deal of information we have about this and how it came to be in Australia and where it was when it was here. I do know that there is another Australian with a jig borer identical to this one. The same company that imported the machine that he has also imported this machine. Probably likely that the two machines were in the same facility, and if that is true, they were in a government facility working on jet engine parts. So the SIP Hydroptic machines, they started out being manufactured in 1934 with the Hydroptic number 1. There were a couple of variants all the way through the series of machines, all the way up to the number 8. The number 6 was where things really started to take off, and then after the 6s, they moved on to the 7s in about the 1950s, 1960s. And that's when the machines became CNC controlled. Larger the number in the build was the bigger the machine. I believe the 8P is the biggest hydroptic machine they built, and those machines can weigh up to 15 ton. This number 6 weighs 8,700 kilos, so 8.7 ton. It's 3.4 meters tall, 3.2 meters long, and 2.4 meters wide. Table size, it's 840 mil wide, 1100 mil long. To move the table back and forward, it's actually hydraulically controlled. So there is a cylinder underneath that moves the table in and out. The way that you engage the table is there is a lever here, which starts the hydraulic pump. The table has 4 speeds. You have 3 speeds for doing any sort of machining, and then its maximum feed rate is its rapid, and it will advance the table whichever direction you point it. So we'll start with the slowest speed, that's 70 mil a minute. And go to speed 2. Speed 2 is about 200 mil a minute. And go to speed 3 is 300 mil a minute, and then its maximum speed. So the travel on the table, so that's all the way out to all the way in, is 950 mil. The way you lock the table up is you disengage the hydraulic pump and that automatically locks up the table from moving in and out. And it won't be able to be moved until you start the hydraulic pump again. Not only do you have your hydraulically controlled feed rates, you also have a hand wheel for your fine adjustments. The hand wheel only works when the hydraulic pump is on and running. So not only does the machine have a scale mounted to the bed, you also have a fine adjustment to make finer measurements here on the end of the table. but it gets finer again. So underneath this little black cover here, we have an optical measuring system. It's this measuring system that really set the SIP machines apart from other jig borers of the same era. The way the optics work is when you are trying to reset a 0 or set a new 0 or something like that, you've found out where you want to be on the table, you need to come down here and set a new 0 for, say, a step over or a step in. Simply what you do, you set your dial to a 0. So we've set our 0 here, but if you look down inside the optic, the little fork that's sticking out is nowhere near any sort of line. So the way to set the 0 and move that line across is done by a little control up here under the table. You wind that until you get your line to fall back in the fork in the optic. So the optics we have down here for the measurements on the table, we also have up here for measuring the head left to right. I don't have a light working in there at the moment, so you can't exactly see what is happening, but it works exactly the same way. Just say you're taking out a new 0, you'll 0 that off. The way you do the fine adjustment on this, like I just showed you on the table, is via this little knob over here. So you simply wind that left or right to reset your 0. The way you turn the lighting on for all of your optics and your table, you have a couple of switches down here on the side of the machine. So we can turn on our screens. You then turn on your indexes. And you also have a day and night feature. So during the day, you obviously run it on day and you can see the optics. During the night, it will dim the light inside the optic to make it easier to see. You also have a table light. And you also have a coolant pump, which comes out of this nozzle here. There is also a lubricating system for the jig borer. There are 3 buttons at the back of the machine that you can push in, and all it does, it just fires a shot of oil into any parts of the machine that need to be lubricated during operation. We have our lubricating area here. Underneath the lubrication area, we have the hydraulic pump, and off to the right-hand side of the hydraulic pump, we have our coolant tank. I haven't put any coolant in the machine since I bought it. I did fill up the hydraulics and the lubricating system, and that's it. The jig borers typically came with a rotary table as well. You could buy them as an electric unit or you could buy them as a manual unit. Like the machine, the table also had very, very fine adjustments for achieving really, really tight tolerances. This machine did have one on it. It was a totally different color. I didn't think I was going to use it because I had rotary tables here. The guy I bought the machine from wanted a lot of money for the rotary table. I don't believe it was worth what he was asking for it, but in hindsight, I still wish I bought it. To move the head side to side on the machine, there is generally a wheel here, which is a rapid traverse wheel. It got broken off at some stage of its life. I'm not sure when that was. I do need to come up with something there to refit that. The other way the head moves side to side is you have a knob here, which drives this lead screw, which drives the head back and forward. Pull that out. There are 3 speeds in either direction. Speed 1 is 23 mil a minute of travel across the machine. Speed 2 is 35 mil a minute. And speed 3 is 70 mil a minute. The travel on the spindle across the bridge is 700 mil. Same as the table, the machine does have its power feeds, but it also has a fine feed. So to use the fine feed, you push this knob back in, and then you wind it by hand. And it is extremely slow. This handle here is the lock for the cross travel. So this handle must be down in the locked position in order to use the electric drive to drive it across. You only unlock it when you are rapiding using the hand wheel that I don't have. The bridge is also power feed. You can lift and lower the bridge by this lever here. The travel up is 900 mil. So you've got 900 mil between the table and the spindle nose when the bridge is at its highest point. The way the bridge is lifted and lowered, behind these 2 tubes on either side of the machine, there are lead screws. Those lead screws then run up to the top of the machine into a gearbox, and then they're run by a single motor for lifting and lowering the bridge. The bridge also has a lock on it, so it's in the unlocked position at the moment. When we lock that, the power feed does not work. So it needs to be unlocked in order to re-lower the bridge. So there is one speed for lifting and lowering the bridge. The fine adjustment for the height will come from your quill on the spindle of the machine. You do have a lock here, which if we unlock that, we'll then wind the spindle all the way down. Lock that back in place. The length that the quill can actually travel is 280 mil. That was one of the main reasons why I bought the machine. Such a long quill travel is really good for boring some of the deeper jobs that I do. I can do them in a single pass without having to set up a line borer and do it like that. The movement of the quill up and down can be either done by hand or fed automatically by the machine. On the auto feed, the way you set it to stop at a height is after you've engaged the automatic feed, you then rotate this wheel around to the desired depth you would like to drill the hole or bore the hole. So you set that to say 20 mil, you push these two levers in that are here and they will start to advance the quill down. Once it hits the 0 mark on that dial, it'll disengage the quill and stop it from feeding. So you also have a fine feed on your quill, so you do that by this wheel here. You also have a dial indicator on the side of the quill for doing really fine adjustments. Once you've achieved the height you want to work at, you then set your dial indicator to a 0. Unfortunately, this dial indicator is seized, so I will have to pull it apart and try and fix it. You can then bring this up to your dial indicator, which is basically just an end stop. Zero out your dial, and then you can advance it however far you want to using the hand wheel on the machine. There are 6 different feed rates for the quill travel. The way the feed rates work, you have basically a high and a low range. You have 2 levers up here, and that designates which range you're in. When you're in the top range, that arrow is pointing at the 0.35. When you turn it to the bottom range, it's now at 0.10. So the slowest feed rate is 0.04 of a mil. And the fastest is 0.35 of a mil per rotation. So everything you can do with the gears and the quill travel, you can also do in reverse. The same feeds and speeds, you can just travel back up. All you have to do is push this lever up. So you do lose a little bit of your quill travel because when this is in all the way up position, that is how you remove your tool. So I can now turn that spindle. So it's unlocked a mechanism inside to then remove the tool. When you come back down, that is now locked up solid. So it's now re-engaged, so you do lose 30 odd mil. On the spindle, we have 18 speeds. We have 18 forwards and 18 in reverse. From 40 RPM up to 2000 RPM. So to start the machine, you have a start button over here and a stop button. You also have one on the other side of the machine if you're working on that side of it. Not only does the machine have a boring and milling function, it also has a tapping function. So when you flip this switch down to tapping, start the machine, it'll run by itself. But when you want to reverse the tap back out of the hole, you don't have to stop it, you simply push reverse and hold it in. So there are a few things I need to fix on the machine before I'm going to put it into service. I do have some damage to my way covers at the front of the jig borer. So it looks like someone's dropped something heavy on there and they've split the covers. So I do need to fix that. I am missing the rapid wheel off the carriage to move it side to side. I'd like to fix that. There are a handful of bolts that I am missing. I'm going to get a friend of mine to make up some bolts for me because I just don't have the time to do it. And the bulbs in the optics. So once I get all that sorted out, I can then put it into service. What's this one? What is it?
I don't think this is for homeless.
You probably have better luck opening it. Oh, it's a knife.
Wow.
With my name on it.
Fancy.
Very. So thank you, Tim, for the multifunction knife. It's been my new letter opener. You're not helping.
Oh, what is this?
He can smell it.
Yes. Oh,
Kill it.
what you got? Oh.
Right, so something else that's really cool about this machine that I was unaware of until I read the book to find out how I was supposed to lift the machine when I had to move it from where it was in the workshop to where it is now. So I was reading through the book and discovered that there is a hole that has been manufactured into the casting in the front of the jig borer in order to lift it correctly. There is a hole at the back, but it is visible without removing any covers. So after removing the front cover to then expose that hole to rig the machine correctly for lifting, I found something. That there is the hole that you use for putting a big bar through in order to lift the machine when you're trying to move it. And that's when I pulled that cover off, I found this. So what all this is, these are spare parts for the electrical on the machine. So we have some spare contacts for the switches for the forward and reverse. Oh, someone's done a drawing of the switches. We've got some spare contacts, fuses, and a few other spare parts, which I don't know what they are just yet. Probably not a lot of people know that those are hiding in underneath this cover. So it was pretty exciting to find them. So not only did we get the original manual with the jig borer that shows original specs, lengths, heights, widths, weights, pretty much anything an operator would need in order to use the machine is in that book. We actually got a second one with the machine as well. Both books are pretty much exactly the same. There is a little bit more information in the newer book. Not really sure why it came with two. Maybe the guy who owned the machine or the company who bought it decided to have a spare one just in case they damaged the first one, and this might have just been a bit more of an updated booklet for the machine. One of the other books we got with it is all the schematics of the machine. So it has everything in it, from your electrics to your hydraulics to your gearboxes to everything. It gives you torque specifications for bolts, tolerances for all the different gibs on the machine. It gives you everything. So if you want to rip this thing down and rebuild it, that is the book you're going to need. One of the other books we got, it's a booklet on angular spacing, which gives you so many different dimensions that I have never even looked at before. It is mind-blowing that someone sat down and worked all this out. This book is just full from top to bottom of all different measurements to make whoever was using the machine's life a lot easier. And randomly, in amongst all the paperwork, I did find the actual sales brochures. So we do have one for a 7P. And for the Hydroptic number 6. So that's pretty cool. And we also got a booklet of tooling and accessories that were available for the jig borer. There is nothing you couldn't achieve with the amount of tooling that is available for them. One of the best parts about this machine and the deal we got with it, we ended up getting a lot of genuine tooling with it. So in this tool chest, we got a lot of boring heads of all different shapes and sizes. We got a couple of different sort of centering devices that you put up in the spindle. We've got a few spare parts, spare tools like genuine Allen keys for undoing the grub screws that hold the high-speed steel bits inside the boring heads. I'm just going to explain a little bit about why some of the boring heads look so different to the other style boring heads that are here in the box. The quill on the machine, the taper in the quill is an MT4, so Morse taper 4. A Morse taper 4 in today's language has an M16 drawbar in it. This machine has an M14 drawbar in it, so you can't just grab random tools off other machines and use them on the jig borer. They need to suit the machine perfectly, otherwise they don't work. This here is the standard Morse taper 4 with the M14 thread that suits the drawbar and suits the spindle of the machine. So that's the standard one. It works off the Morse taper itself in order to apply friction to the spindle to drive the boring head in order to do whatever you're doing. The bigger boring heads, they don't use the standard Morse taper in order to hold the tool central in the spindle. So that all comes down to another style of taper locking system that is exclusive to SIP only, as far as I'm aware. The bigger style has a parallel shaft on it, which is just straight up and down. Same M14 thread in the end of it. They don't rely on the Morse taper 4 taper in order to drive them or add support. They rely on this other taper, which has the male version on the machine and the female version on the tool. There are two flats machined onto the arbor itself, and they must correspond with the machined area in the bottom of the spindle. That is also used as the drive. So that just adds a great deal more rigidity and precision for the bigger boring heads. So the way that you remove the tools from the jig borer is you have to take the quill all the way to the top. That will then lock up your drawbar, but it unlocks your quill, and you simply use the big spanner that they give you to then unlock the tool from the spindle. So what comes in this box is all the tools and the cutting bits for the boring and facing head. Unfortunately, the box is pretty beaten up and the boring head doesn't currently fit in there because it still has a tool in it. So it's an automatic facing head, gets put in the machine like any of the other tools do that have that big collar on them underneath for support. And this can be used for facing off something or getting down inside a bore and then cutting a, say, a snap ring groove or an O-ring groove. This is the extension so you can reach larger diameters. So you simply unscrew that one and screw that one back in its place. So we also got 3 boxes of the optical measuring equipment that comes standard with the machines. So we do have a center finder here. So that gets put up into the spindle. You can then look through this glass here and center down on top of a point that you are trying to drill and or bore. This is another part of the optics. I'm not 100% sure how this one actually works. I am going to go through the book and find out exactly what it does. I believe it is for setting level of the machine, but don't quote me on that. This plugs in down here. There are a few parts missing, so we can't actually plug it in to see what it does, but that's just another thing that came with the machine. So I haven't actually worked out what this does yet, but I'm going to go through the book and try and figure out what it's for. I don't think this box belongs in this particular case. I believe it belongs with another one. So with all the tooling, we also got a box of miscellaneous stuff. There's mainly bulbs and fuses, a few different sorts of little tools and accessories that probably belong in these boxes. Some of these T-handles, they suit a lot of the fixtures on the machine. So I'm gonna go through all that and try and piece all these kits back together. So that's all the tooling and accessories we got with the jig borer. I am gonna put this into service. It probably won't be for a while. I do have other projects I need to get out of the way first. It was just too good a deal to pass up considering what I got with it. If I ever do come across the SIP number 8, it is something I will definitely do my best to try and get. But for now, we're very happy with the number 6. It's going to be a joy to work with this machine, being its era and what it is capable of doing. We are also interested in any of the Hydroptic number 6 tooling, accessories, tooling cabinets. So if you know anybody that's had a machine that may have spare parts, or you know of any spare parts or tooling getting around, drop us a comment or send us an email. We'd love to hear from you. So we hope you've enjoyed the walk around of our jig borer. Thanks for watching. How you going, guys? Curtis from Cutting Edge Engineering. So today's video, we're going to be revealing our SIP We've sort of figured it out that the hydroptic means it's hydraulically driven and it has optics. Made by... What?
You can do it. You can do it.
I don't want to say that. I might offend somebody. Societe Genevoise.
You probably just swore at someone somewhere.
Someone hates me right now.
I'm gonna get closer.
No, don't. Fucking back up a little bit. Ready?
Yeah.
You got back to where you were.
It's fine. It's good.
It's too fucking close.
Do you want to put your arm down?
Right.
Just lean on the side there. There you go.
Right.
Yeah.
You want me to unfold my arms?
No, that's
Can't
fine.
tell.
That's fine.
I don't know its history. I don't know who. Oh, I do know actually.
What?
The way I come to have this machine is I was in the market for some. I was in the market for a new not new. I was.
Oh my lordy lord. Save me, Jesus.
Can't help you. So the tolerances you can hold with the. I try not to say machine so much.
Yeah, that's good because you say it a lot.
Yeah.
Come on, words.
Come on.
Why not working?
It is working. It's moving.
Oh my god.
You then lock it and none of the power feed will work.
Okay.
Until you unlock it.
Okay.
Right. But that's also down here as well.
Ah, my brain.
Okay, come back over here. And you have a dial here. Oh, fuck.
Knob. So it's obviously...
Bang!
Dickhead.
Fuck off, train. You... Fuck off. Fuck off. Right, so the optics we have down here on the table for measuring...
The table.
We also got a tooling and accessories booklet from the jig borer.
Okay.
Start again. Right. So the other booklet. So the last. Oh fuck man. You're right.
It just needs to make sense, is all, and sometimes it's
Okay.
hard making you make sense.
Okay. Right. These. And. Oh fuck. It's one of the. Oh, fuck man.
What are you trying to say?
I don't know. These were built. Fuck. So that's our Hydroptic number 6 jig borer. Oh, fuck. So that's how the. And. Oh, fuck. We hope you've enjoyed. Right, stop. And.
Oh, hi. Hey, wake up. Oh.
Idiot.